Pre- and post-harvest moisture loss studies in pears presented by Asanele Same under the supervision of Anel Botis from ARC Infotech and Dr. Elke Crouch from Stellenbosch University. Just to give a bit of a background to the study, pears lose a lot of moisture due to transpiration from when they are harvested until they reach the consumer. This is because they are now detached from the tree or the mother plant, which supplies them with water. The rate at which moisture is lost is driven by environmental factors such as temperature and relative humidity. However, the amount at which moisture is lost depends on product characteristics such as cultivar type, peel characteristics, and packaging. I am going to focus on two objectives of the study. The first one is looking at the commercial pear protocol and vapor pressure deficit from harvest to shelf life on shriveling. For this objective, two pack houses were identified. One is Dutoit in Ceres and Wolfpack in Worsley. And from each pack house, 2 farms were used with 3 orchards per farm. From commercial harvest until after 7 days of shelf life, temperature and relative humidity were recorded using eye buttons. So one eye button was put inside the fruit, which recorded the temperature of the fruit at 100% relative humidity, and 2 other eye buttons were put in the middle of the bin. These were recording temperature and relative humidity of the bin, the whole bin. These are the results of the vapor pressure deficit of La Placenta farm in Wolfpack from harvest until after 7 days of shelf life. As we can see, vapor pressure deficit is very high at harvest and picked up again during packaging before RA storage and picked up again during the 7 days of shelf life. This is due to the fact that temperatures are high at this time with low relative humidity. So high vapor pressure deficit may lead to weight loss and shriveling, so these periods need to be kept at minimum. The second objective of the study is looking at the effect of cooling delay and tree position on shriveling. Please note that there was no interaction between cooling delay and tree position. Table 1 is showing shriveling classes of different cooling delays after storage periods. So after harvesting, fruits were subjected to 4 cooling delay periods, which are 4 hours, 8 hours, 16 hours, and 32 hours, before they were stored in CA for 8 months, 6 weeks in RA, and 7 days of shelf life at 20 degrees. So after each storage period, fruits were evaluated using the shriveling classes shown in figure 3, and it was found that class number 4 was increasing as the cooling delay period increased. Figure 2, which is showing the effect of cooling delay on shriveling. Weight loss was recorded to be at the highest at 16-hour cooling delay, which shows that the cooling delay period needs to be kept at minimum as it makes the fruits to shrivel and lose moisture. In conclusion, handling period such as harvesting to cold storage period, the packaging period, and the shelf life period needs to be minimized as they may lead to wilting and shriveling. Also, pears continue to lose moisture during cold storage, so it is important to keep the temperature differential between cooling medium and cold room as small as possible. So low temperatures and high relative humidity are very crucial to minimize the rate at which moisture is lost during cold storage. Thank you.